my hero, Dr. Anthony Fauci. Okay, it's set for Olympiad one time, kids. Let's do it. What I do with a book. Did I leave the book? Oh, it's over here. Always have your materials at the ready before pressing the go button on your video. Learn from my mistakes. Okay, here we go. For how many different counting numbers? 10, between 10 and 200. For 10 to 200, okay. Is the sum of the digits equal to 6? If zero is not, no zero, you cannot use it. So, between 10, so we got to start at 10. So we go from 10, so that's going to be a 1 and a 5, because 15, 1 plus 5, that gets you, so that works. Bing! And then, is that it? Yeah, 1 and 4 is going to be too small, and 1 and 6 is too many. So we're done with the 10 numbers. So now we go to 20-something. Well, that's going to be 2 and 4. And that's going to be the only one. And then we go to 30-somethings, which would be the 3 and the 3. And then we go to 40-somethings, 4 and 2. And 50, 5 and 1. And then we go to 60. No, we don't. That has a 0 in it. 70s, 80s, 90s. Nah. We can't do 100 through 110. They all have zeros. So now we're up to the 100 teens. So 1, 1, and 4. That adds up to 6. So that gets us through with those. Then we go to 120, that's 3. Then 130 and 2. 141. We can't do 150 because it's got a 0 in it. By the time we get to 160, then we still got a 0, but in the 160s, then we're going to have too big a number. So it's, how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. And I even checked in the back of the book, and I'm right. 9. 9 numbers, and those are the numbers. How'd you do on that? That's number 1. Let's do number 2. Number 2. The perimeter of a rectangle is 26. So we got here's my rectangle. Well, not a very good one, is it? But let's just do it anyway. My perimeter is 26. So P equals 26. It's really pronounced perimeter, I know. I'm not stupid. All right. Each side is measured in counting numbers. That's what they mean when they say whole numbers. What is the greatest possible area? Okay. Here's the way to do this. You add them all up, and it equals 26. But we know that this is the same distance as this, and these two dudes are the same. So guess what? If it's all the way around is 36, these two added together have to be half of that, which is 13. So that plus that is 13. Okay, so one side plus one other side gets us 13. So now we start thinking, what could this sides be? For 13, I'm going to make a little table. Okay, I'm going to erase that. I'm going to make my table, which will be the dimensions, and this will be the area. Okay? All right, so if it's 1 by, let's see, if it's 1, it'd be 1 and 12. That area would be 1 times 12 is 12. If it was 2, they have to add up to 13 each time. So it's 2 and 11, that would be 22. 3 and 10 is 30. 4 and 9, 36. Hey, the numbers are getting bigger. Look at that. 5 and 8 is 40. And 6 and 7, which is 42. And by the time we go up to 7, then we're back over at 7 and 6. So this is the total number. The biggest number is, boom, 42. But what did it ask you? What is the greatest possible area in square units? 42 square units. Next is up to Brian. Brian, who's got some serious issues. Why? Because Brian doesn't know how to spell his name. B-R-Y. Hey, come on, dude. Figure it out. Okay, he's got a racket going, though, so he's not bad. He can sell, he can buy 4 for 50 cents. 4 of these candy canes. And then he turns around and he can sell 3 of them for 50 cents. So how many does he have to sell until he makes a profit of $5 Because what's he going to do with that? He's going to go down and he's going to get him a good slice. 2 slices, actually. Pepperoni down at Maggio's or something. I don't know. A matzah. Okay, so this is his profit action, right? So every time he buys 4, he can turn around and sell 3 of them for 50 cents, and he has 1 left over, 1 little doodad, right? But I'm going to think about this. If I want to make $5, guess what? $5 is 10 times bigger than 50 cents. Once I have 10 50 cents together, I've got $5. So if I need to earn 10 times this much, I need to be able to sell 10 times that. I need to get a pile of 30 extras, 30, that are sitting around and I don't have to buy anymore. I can just keep selling. Not I, it's Brian with a Y. I can keep selling those 30, right? And that will make me the $5. Okay, so I'm gonna make all the profit at the end. So how long, so if I'm gonna be able to get this going, I'm gonna have to do this 30 rounds, because each round I only save, so I buy 4, sell 3, and I get 1 candy cane left. So I get 1 of these after the first round. I need to end up with 30 of these suckers in order to make my profit. So I have to do 30 rounds of this process. Well, the question is, how many must I sell? How many candy canes must I sell? I'm gonna do 30 rounds. So each time I'm selling 3 of them. So if I sell 30, then I'm gonna have to sell 90 of them to get my my thing of 3. Now I'm cheating. Is it 90? Oh yes. Okay. I do 30 rounds. Okay. So I've now sold 90 of them. I've sold 90 so far. I now have the pile of 30 left over, and I'm going to be selling those and just making my money. But that's the last 30, so it's 90 and 30, so it's 120. If I sell 120, I'll make the money. I don't feel like I explained that very well, but you're smart. You can handle it. Okay, let's do the next one. It made sense to me, and that's really what's important here. Okay, number 4. A supermarket clerk makes a big stack of cereal boxes. The top layer is shown. So the top layer is 1 by 4. That's 4 boxes. We're gonna have to count up. We're just gonna make a little table and add up the numbers. This one's not very hard. Next one has 2. It's 2 by 5. So that's 10. Next one's gonna be 3 by 6. And that's 18. And then 4 by 7. 28. And 5, 1, 2, 3, 4, 5, yeah, 5 by 8. Let's add them up. All right, 4 and 0, 4. Okay, 12 plus 8 is 20. 0, carry the 2. 2, 3, 4, 5, 6, 10. 100 cereal boxes. How many are there? What is the total number of cereal boxes in these top 5 layers? 100. Hope the guy didn't keep going. Now, we're up to some dude with some serious weird ducks. Okay, a normal duck has 2 legs. Thanks for that information, the background knowledge. A lame duck has 1 leg. That's weird. And a sitting duck has no legs. So remember this, kids. If you're hungry and you're looking for something to eat, and you see a duck standing there, and then you see 1 duck that's lame and 1 duck that's sitting, which one do you want to grab? The sitting duck. It has no legs. It can't get away. Look, it's still going to fly, though. Back to the point. Okay. We know that Donald's got 33 ducks. Okay. I'm going to use algebra to solve this one, so you can check it out. So, he has 2 more normal ducks. Okay, we're just going to say that X is equal to the normal ducks. That's the number of normal ducks. Okay, so if he has 2 more normal than lame ducks, so that means if I do the normal ducks minus 2, I get lame, the number of lame ducks. Just work with me here, okay? Just calm yourself. And then if I take this number and I took 2 more away from that, that would be the number of sitting ducks. So it would be like x minus 2 minus another 2. Well, guess what? That's the same as, what is it? X minus 4. I'm just going to write that. X minus 4 equals sitting. All right. Looking like algebra, right? We're using letters to represent numbers that we don't know the value of yet, but we will. Now, I know if I add all these things together, the number of lame, sitting, and normal, I have to get to 33. So here's what I'm going to do. X plus x minus 2, I'll put it in parentheses, plus x minus 4 is all equal to 33. Okay, with me? Now I'm going to combine all these things. Since we're just adding things and subtracting things, I don't even need to put these. So what I'm going to do is I'm going to combine my x's, I'm going to combine my numbers. So x plus another x plus another x, guess how many x's that is? It's 3 x's, and the way you show that is 3x. When you see a number and a letter right next to each other, it means they're multiplied together. So 3 times x. And now I have a minus 2 and a minus 4. When I put those together, it becomes a minus 6. That equals 33. All right. But what you do in algebra is you want to get all your x's on one side and all of your numbers on the other side. So if I want to make this 6 go away, you can't just erase it because then it won't be equal anymore. Equal means it's in balance. But if I do the same thing to both sides of the equal, then I'm cool. So what if I added 6 to this side and added 6 to this side? I'd still be in balance. Think of this as a balancing side. So I'm going to do that. When I add 6 here, those go away. Negative 6 plus 6 makes it 0. When I add 6 to here, guess what it equals? 39. So 3 times something equals 39. What's that something? It's 13. So 13 is the number of normals. And 13 minus 2, 11 is the number of lames. And 11 minus 2 is 9 is the number of sitting. So now I've got to go back to the question. It says how many legs? Doesn't ask you for the 13. It asks you how many legs are total. These guys have no legs. They're done. I don't even care about those. They're dinner. Okay, next, these guys have 1 leg each, so that's just 11 times 1, which is 11. These guys have 2 each, so that is 13 times 2, which is 26. Add them up, I get 37. That's the answer. And that's the end of this Olympiad. Thank you.